Hello everyone. In this video, we'll discuss Unit 4 of Machine Learning Algorithms, which is Supervised Learning. The course outcome of this unit is to utilize unsupervised learning approaches to solve real-world problems. So we'll learn how machine learning discover hidden patterns and structures from unlabeled data. Unsupervised learning. So unsupervised learning is a machine learning technique in which model learns from unlabeled data. Unlike supervised learning, there are no predefined target outputs. The objective is to discover the hidden structures, patterns, relationships, and lie within the data automatically. So the applications include customer segmentation, recommendation systems, anomaly detection, and market basket analysis. Unsupervised learning is basically classified into two categories. One is clustering and association rule learning and dimensionality reduction. Clustering groups similar data points together, and association rule learning identifies the relation between and among the variables, while dimensionality reduction reduces the number of features while preserving the important information. So these are the various categories of the unsupervised learning. Clustering. So the two primary strategies to extract the signal from noise is clustering and dimensionality reduction. We'll discuss clustering initially. Clustering is the process of dividing data into groups called as clusters. The data points within the same cluster are similar, whereas the data points in different clusters are dissimilar. Clustering is widely used in customer segmentation, image segmentation, document organization, and bioinformatics. K-means is one of the most popular clustering algorithm. The algorithm works in 4 steps. The first step is select the number of clusters, then initialize the cluster centroids, and then assign the data points to the nearest centroid. And once you assign the data points to the nearest centroid, update the centroid and repeat the same process until it converges. So K-mean is a simple, efficient and widely used in industrial also various applications. Hierarchical clustering builds a hierarchy of the clusters. There are two approaches under the hierarchical clustering. One is agglomerative clustering, another one is a KNN clustering. So hierarchical clustering. Agglomerative clustering starts with the individual points and merges them. And the second one is divisive clustering. It starts with one and divides into smaller clusters. The result is represented using a dendrogram. You can observe in the slide showing towards the right down side, which visualize the cluster relationships. Associate rule learning clustering identifies the interesting relationships among variables in the large data set. A common example is market basket analysis, where retailer analyzes the customer purchasing patterns. For example, customers buying bread may also buy butter. This helps business improve marketing and product recommendations. A priori is a popular association rule mining algorithm, and it works by identifying the frequent item sets and generating the association rules and measuring support and confidence. A priori is widely used in retail analysis, recommendation systems, and customer behavioral analysis. Many datasets contains a large number of features, which may increase the complexity and computational cost. So, there is a need of the dimensionality reduction. This clustering helps by reducing the redundant information and improves the computational efficiency, enhancing the model performance, and it is also simplifies the data visualization. The two common techniques are PCA, principal component analysis, and LDA. PCA is a statistical technique used to reduce the dimensions while retaining maximum variance within the data. It transforms the original features into new variables called as principal components. The advantages includes it reduces the computational complexity, also it eliminates the noise and better visualization and it is also improves the machine learning performance. Coming to LDA is another dimensionality reduction technique. Unlike PCA, LDA focuses on maximizing the class separability. It is commonly used in face recognition, speech recognition, medical diagnosis, and pattern classification. So LDA improves the classification performance by preserving the discriminative information. Let us summarize the unit. We studied unsupervised learning and its major techniques including clustering, association rule learning, and dimensionality reduction. We also discussed k-means clustering, hierarchical clustering of two types, agglomerative and divisive clustering. Also PCA, LDA along with their applications. So these techniques helps extract meaningful information from the unlabeled data and are widely used in data mining, pattern recognition, and particularly business analytics. Thank you.